In this demonstration, we will look at the use of origin to transform data to prepare it for plotting, create a plot, fit the line, and examine the line fitting in two ways, using the R-squared value and the residual plot. I have in my sheet some temperature rate constant data. To complete an Arrhenius plot, I want to plot the natural log of K against reciprocal temperature, with temperature in Kelvin. Firstly, we will create some columns. We can use the column menu or just select Ctrl D on the keyboard. I'm going to add 3 columns. We can add more at any time. I now want to use these columns to transform my experimental data. To transform a column, we can go to the column menu again or select Ctrl Q. Column C will be used to transform the temperature into Kelvin. So in the calculation box, I enter in the range of rows I want to transform, 1 to 6 in this case, and the transformation. So column C will be equal to column A plus 273. Press apply to make sure it has worked as you require, and then press OK. I can repeat for column D, which would be the reciprocal of temperature. Of course, I could have completed both of these transformations in one. Here I have pressed apply and spotted that I forgot to enter in the row range, so I can change that to 6 and update it. This column is going to be an x-axis, so I can right-click on the column and choose Set as x-axis. Finally, column E will be the natural log of column B. The syntax involves bracket around the column name after the function name as shown. Now that I have my data set up, I can create a plot. It's easier not to highlight the data, so just click anywhere on the sheet and select Plot menu, Symbol, Scatter. You see here we have much more control over what is going to be plotted. I select my x-axis and y-axis as required and select OK. Now we want to fit this data. After clicking on a data point, we can select Analysis, Fitting, Linear Fit, as the data is modelled by the linear form of the Arrhenius equation. In the dialog box, most default options are usually OK. Under the Fitted Curves Plot section, it's better to switch off the Update Legend on Source Graph option, as it clutters the graph unnecessarily. Under the Residuals plot, note that Residual versus Independent plot is ticked. We will use that later. Once you press OK, the Bestfit line and output is presented on the graph. Let's look at the output. We can see the intercept and slope values here. They will be used to calculate the Arrhenius parameter A by getting the exponential of the intercept, and the activation energy EA by multiplying the slope by the negative gas constant, in accordance with the linearized form of the Arrhenius equation. We can calculate the standard error in these values in an analogous way. What about the goodness of fit? The Bestfit line is chosen so that there is a minimum distance between all of the points on the line. It is common to look first at the R-squared value, but R-squared should only really be looked at once the residual plot has been examined. To examine the residual plot, we can go back to the spreadsheet and select a new tab that has been generated as a result of fitting, Fit Linear 1. Here we see the residual plot. Double-clicking makes it larger. What are we looking for? In general, a residual for a good fit will show random scatter either side of the fitted line, represented by the 0 line here. There should be no obvious trend on one side or the other, for example, all points below the line at one end of the plot and above the line at the other, or a gradual drifting of the scatter one way or the other. This residual looks okay. Perhaps the highest data point is skewing the data somewhat. Once we've looked at the residual, we can now examine the R-squared value, or the coefficient of determination. It gives us a sense of how closely the points fit the matched line. We usually look for a value as close to 1 as possible, and here a value rounding to 0.95 is satisfactory. We need to take caution with R-squared. It must be used in conjunction with a visible inspection of the plot and residual. However, having examined the residual and R-squared values, we can conclude from this plot that the data is well represented by this fit and take the slope and intercept values from it with confidence.